Now let's jump into integration techniques. There is several techniques that you can use in order to find or to solve any integration related problem in a short period of time. The first technique we're going to talk about is the substitution. Sometimes you have a complicated integration that needs you to do a couple of substitutions for certain expressions of that formula to be able to find the final answer in the old simple methods of solving integration. This substitution could come into three main formulas or three main forms. Either you have a certain expression that been substituted as u to a certain power of r du, then you will solve u same as the equation for x to the power of n. It's a power rule in this case of integration, and you can find your final answer, plug in back your substitution as the original values, and you'll have your final answer. You can have it to the power of u, like e to the power of a certain expression. You can substitute that expression as a u and find your final answer. Then you can have it as 1 over u, like there's a certain value divided on a second value, then you can be able to find that through substitution. Let's take an example and learn how to do that. So the strategy of substitution: first you decide which rule you want to follow to be able to find your integration, and if you believe it's a power rule, then you let the u be the base. If you believe it's exponential rule with the base e, then the u will be the expression in the exponent of the e, and if it is a natural logarithmic rule, then you let the u be the denominator in this case. Then you determine your du, then you inspect the integration and be sure that you substitute the accounts for all the factors, and sometimes you may need to insert a certain constant as needed. Then you perform the integration and you reverse the substitution, means you plug in back all the original values that you substituted with a certain variables like u in this case. Let's take an example over here. You have the integration of 3x minus 4 to the power of 7 dx. I mean, if you need to distribute the power inside, it will be complicated, while you can take a simple approach by only making the u to equal the expression 3x minus 4. Then this would be the integration of u to the power of 7 dx. So u is 3x minus 4. Now it is a good practice to find the du. Du means the derivative of u, as you remember. Du in this case, you're deriving the 3x, it would be 3 dx. So you derived this expression in terms of dx. So du was equaling 3 dx, as you can see here, and du over 3 would equal dx. Like if you say what is dx in this case, that's du over 3. Now you have the integration over here, so this integration would equal, after substitution, u to the power of 7 du over 3. Remember, you have this as a u and you have the power of 7 as it is. Dx, what does it equal? It equals du over 3. It's important to take care of that. Dx doesn't stay as dx, it is du over 3. To do the integration for the u, it should be in terms of du. You are doing the integration with respect to du in this case, and the 1 over 3 constant will go outside. Now u to the power of 7 is same as x to the power of 7, but it is in terms of u in this case. That's equals u to the power of 8 over 8 multiplied by that constant plus c, the integral constant, or the integration constant in this case, and your final answer would look like this. I'm sure you are already familiar on how to follow up this kind of equations, as long as you did the substitution in the right way. So when you reach this point where u to the power of 7 need to have integration, it's easy for you. Just you need to do the first step, having the u in the right place to substitute the right expression. Then make sure you express the dx related to du, and that would give you the final answer. Then when you already solved the integration, then u will come back to be as 3x minus 4, as we can see here, and you plug it in whenever needed, and you will have your final answer, as simple as that. So here's an expression that you can use in order to solve this kind of substitution in a straightforward way that I found through my research. So if you take the integration, you already substitute as a u here. Now the integration of u, so the integration of u to the power of 7 du, what you do instead of looking at dx equal du over 3 or whatsoever, you can just only multiply that by 1 over u prime. So you have here u as 3x minus 4, then u prime, you already know how to do that, equals 3. Now here you do the integration in terms of u, that's u to the power of 8 over 8 multiplied by 1 over u prime. If you bring back the variables that you substituted, that's 3x minus 4 to the power of 8 over 8 multiplied by 1 over 3. 3 by 8 is 24, that's 1 over 24 multiplied by 3x minus 4 to the power of 8 plus c, of course, because you did the integration over here, you need always to have the integration c, and that's exactly this answer. So you can use the formula. After you do the substitution, you can say the integration of u du multiplied by 1 over u prime. That's it. You get your final answer, as simple as that. In case you are confused on how to manipulate the dx, it's basically giving you a simpler form on how to get the right dx relative to du. Let's take another example. You have here two expressions multiplied by each other, one to the power of 10, the other one to the power of 2, dx. Now, what we're gonna substitute in this case, so you can substitute u in terms of this expression, and the du would be in terms of dx and 3x squared. That's a different way of substitution. So you can have u as x cubed plus 1, du as 3x squared dx, right? Then in this case, dx would be du over 3x squared. Now, what we did here, we substitute the u and du, so the integration would be integration of u to the power of 10 du. As simple as that. Then you do the integration, that will be u to the power of 11 over 11 plus c. So that's u to the power of 11 plus c. Finding dy, dx, and du. Sometimes you have questions in this form, y equals x to the power of 3 or f of x equals x to the power of 3. What is dy? So we have y here. What is dy? Then we know, of course, from before, dy over dx equals the f prime. Now, if we do f prime for this term, would be dy over dx would equal 3x squared. Now, what is dy? dy in this case, it's like 3x squared over 1. Then you do cross multiplication. dy equals 3x squared dx. As easy as that. Now you have u equals x to the power of 2 over 3. Find the du. Of course, here du over dx means we are derivating the function of u with respect to x would equal 2 over 3 x to the power of minus 1 over 3. In this case, du would equal 2 over 3 x to the minus 1 over 3 dx. That's a good point to cover if you want to find specifically dy, du, dx, so that you'll not be confused. It's all derivation related. And if you need to use the integration for the du or dy, just make sure to represent the variables in terms of each other to be able to solve them in a convenient way.